Today we're going to talk about complex fractions, and essentially what a complex fraction is a fraction divided by a fraction. In high school we're going to see it like this. In 6th grade we saw it like this. And in 6th grade basically we knew to take and write the first term down and multiply by the reciprocal of the second term, thus 7/8 in this problem. Now, if you feel comfortable, you can do the same thing every time with these. You can write the first term down, multiply by the reciprocal of the second. So you'd think, well, this is kind of a joke. Why are we showing you this? Well, things get a little more complicated, kind of like this problem. And we can, once again, use the same concept as we did before, multiply by the reciprocal of the denominator to the top and get the answer. The only caveat is you have to have a singular fraction in the numerator and a singular fraction in the denominator to do this. So in that case, you've got to do the additions and subtractions first, get that answer, and then multiply by the reciprocal. And I'm going to show you two ways to go about doing the same process. The first way is the old school way. Find the common denominator on top, do that. Find the common denominator on bottom, do that, and then multiply by the reciprocal. So let's go ahead. Common denominator is 8. So what I've really got is I got to multiply by 2 and 2 here, thus giving me a 6/8 minus 1/8 over common denominator is 12, so 4 and 4. Notice in each of these cases I'm multiplying these numbers by 1, so I'm not changing the value of the fraction at all. So I have 4/12 and 1/12 combined like terms, and I have 5/8 over 5/12. You'll notice one fraction in the numerator, one fraction in the denominator, so now I can take and say, well, that's 5/8 multiplied by the reciprocal of the denominator, and now I've got reductions that happen. The 5's reduce, 12 and 8 have 4 in them, so we get a final answer of 3/2. So that's one way to do the problem. The other way is to look for a common denominator of both the numerator terms and the denominator terms. So if I see I have 3, 12, 4, and 8 in that pool of numbers to find my LCD, I say, well, hey, I've got 24 as an LCD for both the numerator and the denominator. In that case, what I do is I multiply by a form of 1 to both the numerator and denominator. So in this case, that's 24 over 24. And so to not confuse people, I usually do this: 24 over 1 and 24 over 1. Now I'm multiplying each term by a form of 1, so everything should be okay. Watch what happens now. I'm going to take and multiply or distribute this in. So I have 24 times 3/4. Well, what I have then is I have 24 and the 4 reduces to a 6, and I have the 3 left. Notice, no denominator. 24 and the 8 reduces to a 3, and I have the 1 left. Over 24 and the 3 once again reduces to an 8, and 24 and 12 reduces to a 2. So you'll notice I've gone from basically a fraction on top over a fraction on the bottom to just a singular fraction. This is the advantage of doing it this way. There are some drawbacks, but we'll get to that later. That's 18 minus 3 over 8 plus 2, or 15 over 10, or 3/2, same answer. So whatever way you like the most, you go ahead and use. I'm going to fluctuate between concepts just to give you an idea of what it will look like. So in this case, I'm going to take and go old school. We'll find one fraction on top, one fraction on bottom, and then after I've done that, multiply by the reciprocal. So in this case, this term needs a y, as does this term. This term needs an x, as does this term. Notice I'm not multiplying the top and bottom by the same thing, but the numerator is being multiplied by 1, and so is the denominator, so nothing's going to change. Alright, and I'm only multiplying these singular terms. So I have x plus 2y over y and y minus 2x over x. I'm going to now notice that I have one fraction in the numerator, one fraction in the denominator. Now I will take the numerator and multiply by the reciprocal of the denominator. And you'll notice in this case there are no common factors, so really I'm done. And you can leave this in factored form if you wish. So I have one fraction remaining with no reductions. So in this next term, I'm going to use the idea of finding a common denominator for both the numerator and denominators. I have c squared, c, and c squared. And I have to find an LCD for all those denominators, which is just c squared over c squared. And again, I like putting over 1 over 1. So I'm going to distribute this c squared to both the numerator and denominator. In the numerator, I get 9c squared. The c squareds reduce in the second multiplication, minus 1 over c squared over c goes to a c, and c squared and c squared reduce to a 1. You'll notice perfect squares in the numerator, so that's 3c minus 1 multiplied by 3c plus 1 over 3c minus 1, which reduces common factors to 3c plus 1. So in this example, let's go ahead and use the new way once again. I have an x minus 4, an x minus 4, and an x plus 1. So I need the x minus 4 and the x plus 1 in my LCD. That's over x minus 4, x plus 1, so I'm multiplying by a form of 1. Multiply, distribute. You'll notice in this case the x minus 4 is reduced, leaving me with the 3 times an x plus 1. In my denominator term, the x minus 4 reduces. I'm left with that 1 and the x plus 1, and then the x plus 1 reduces, and I'm left with a 3 and the x minus 4. Now you'll notice in this case these appear to be common factors, but since this is an addition, I can't reduce them, just like I can't reduce the 3 either. So I have to multiply everything out. I have a 3x plus 3 over x plus 1 plus 3x minus 12, which gives me a 3x plus 3 over 4x minus 11, and that's all I get for that one. Now on this last one, this looks pretty complicated. Let's go ahead and do it the old way. It may just introduce too big of an LCD. So I'm going to call this 1 over factoring x plus 1, x minus 1. Rule of thumb for me is when it looks like my LCD is going to be too large, I will go ahead and use the kind of old school way of doing the numerator separately, denominator separately, and then multiplying by the reciprocal. So I factor this second term out, and that's x plus 3, x plus 1. In my denominator, I have 2 over x minus 3, I'm sorry, that's x plus 3 x minus 1, and then x plus 3. So now what I'll need to do is I'll need to find common denominators for the numerator, and in this case, if I'm looking across the board, I need an x plus 1, an x plus 3, and an x minus 1. This guy's missing the x plus 3. This one is missing the x minus 1. In this denominator, I just have the x minus 1 missing. And now start multiplying through. In my first numerator, I have x plus 3 over x plus 3, x plus 1, x minus 1, and then minus a 2x minus 2 over x plus 3, x plus 1, x minus 1. All that's going to be over 2 over x plus 3, x minus 1, and x minus 1 over x plus 3, x minus 1. Now I'll go ahead and combine some like terms. Let's bring this back down. Remember, it's not a trick, but remember to distribute your negative to both terms. So I have x plus 3 minus 2x plus 2 over x plus 3, x plus 1, x minus 1 over, distribute the negative to both terms, 2 minus x plus 1 over x plus 3, x minus 1. Combining like terms, you'll see I have a 5 minus x over x plus 3, x plus 1, x minus 1, and a 3 minus x over x plus 3, x minus 1. Now I'll rewrite it, multiplying by the reciprocal. That's 5 minus x over x plus 3, x plus 1, x minus 1, multiplied by the reciprocal. It's x plus 3, x minus 1 over 3 minus x. I look for my common terms to reduce. Looks like I've got an x plus 3 and an x minus 1, leaving me with 5 minus x over x plus 1 and 3 minus x, and I can leave it as is. So that's all we've got. Make sure you fill out your lesson summary and do your Connect Ed, and we'll talk more tomorrow.